Thanks for tuning in to this introductory lecture on the Domain Name Service, or DNS. My name's Professor J Patterson. IP addresses, or Internet Protocol addresses, are hard for people to remember, whether that's the 4 numbers associated with an IPv4 address or the 8 hexadecimal numbers associated with an IPv6 address. On the other hand, domain names like Amazon.com, Microsoft.com are hard for computers to reason with. What the Domain Name Service, or DNS, does is it translates domain names to IP addresses. The motivation for this is pretty simple. Basically, the internet has an enormous number of computers on it that are all networked together and that each have an IP address associated with them so that one computer can talk to another computer. But along come the people. And the people have some motivation for why they want one computer to communicate with another one. Maybe it's to download a cat video. Maybe it's to send an email. Maybe it's to share some kind of a document. And in order to do that, the people need to know which computer they're going to communicate with. While it might be possible to remember a few IP addresses without too much trouble for a person, it's inconvenient when you're dealing with many, many different addresses. And so the Domain Name Service has come along in order to allow us to use human-readable names to reference these IP addresses on the internet. And so in many ways, what you can think of DNS as being is a phone book for the internet. The problem is that given an IRI, another name for a URL, we want to retrieve the IP address that's associated with the subdomain and host of that particular lookup. So for example, my homepage, www.djp3.net, needs to be translated into 104.196.197.90 so that your computer can find my computer on the internet. The solution is the Domain Name Service. This service is provided by a distributed set of servers, not just one, so that there's not a single point of failure. But because it's serving the global community, the latency on these requests can be quite high. And when I say high, I mean seconds for a single request. While that may not seem very high by human standards, if you can imagine that a single web page can take 10, 20, or 100 different translations in order to render all the content, you can see that that would be too long for someone to wait for a web page to come in. So this phone book for the internet has a couple problems. One is that a typical operating system will only allow one lookup at a time from this phone book to reduce the demand on the computer and on the global system. And since a single request can take 10 to 20 seconds, and these requests are blocking, meaning that you can't ask a second request until the first one has completed, that just takes too much time. And so in addition to this phone book for the internet, we also add a layer of caching. What caching does is it's a sequence of places where we store translations from domain names to IP addresses that we've asked for before, so that when we ask for them a second time, we can get the answer much faster. That's a little bit like maybe keeping a Post-it note by your computer with phone numbers of your friends, maybe their office numbers if you need them, so that you don't have to look them up in some sort of phone book every time you need them. You can just look at this small piece of paper with frequently cited phone numbers to speed up your phone calls in a human case. Kind of like a metaphor for what's happening in the caches. Okay, so without caching, the fail-safe method for how we do this translation involves asking a hierarchy of computers what the IP address is that goes with a particular subdomain and host. This is a global service that starts with a global internet registry, but ends up with whatever company you have paid to host your domain. So we start by a browser, and the browser might ask, hey, where do I go to find the content for www.djp3.net? Their first request goes to a set of 13 public servers at a top level that handle all the requests across the entire internet. Now, it doesn't have all of the translations for all the different domains, but what it does know is it does know who to ask next. And since I'm asking for a domain that ends in .net, it will give me a set of computers that are eligible for answering .net queries, and I'll get those back. So the first set goes to the first request goes to rootservers.net, and they're going to come back and say, oh, for .net addresses, you need to go ask gtldservers.net. Okay, so after I ask the root servers, I then go out and say, oh, hey, name servers, again, 13 servers that are responsible for providing answers to all domains that end in .net. Please tell me, where do I go to find www.djp3.net? This second level of the hierarchy doesn't know that answer, but what it does know is it knows who to ask for djp3.net subdomains. And it will answer, and it will say, oh, for djp3.net, you need to go to hover.com. Now, hover.com is a company that I've hired, and what service they provided was to sell me a domain name. And when they sold me the domain name, they also sold me a service that will do this translation from www.djp3.net to my IP address. That's called a name server. So in the third level of the hierarchy, the public internet, the public resources on the internet now say, oh, private company that's responsible for djp3.net, that's hover.com. Go ask them. So now in a third request, my browser is going to go out and it's going to ask hover.com, hey, where do I go to find www.djp3.net? Hover has 3 name servers that I can ask, and so I will ask one of the ones that is provided for me, and they say, oh, you want to go to 104.196.197.190. This is a second company that I have hired in order to host content for my website. It's a company called WP Engine, which is a WordPress hosting company. So now my browser knows where to find the content, and it goes out and it asks 104.196.197.190 to provide the web page that's associated with www.djp3.net. That server is expecting requests like this and generates or has that file available and sends it back to my browser to view. In total, there's 4 different requests here: the global set, the .net set, the djp3.net set, and the www.djp3.net question. 4 different requests for one translation. If you want to see this happen, you can do it manually on the command line. In particular, this will work in a Unix environment or in a Linux environment. Or if you have a Windows machine, it should work in the Ubuntu terminal that is now available for Windows. You can also do it on online tools as well. The command is dig plus trace plus qr www.djp3.net. And what this will do is this will ask the global internet infrastructure to do that translation for you without using any caches. You can see that I've done that here in this screenshot. And my first request went out to the 13 root servers and tried to get the names of those root servers. So I got these 13 root server names back. They've been shuffled randomly so that the load that's coming from all across the internet is distributed evenly across all these different servers. So to these servers, I ask, hey, who should I ask for a .net domain? Now notice in the left column, there's a dot all the way down the left side. That says I'm looking for the global, high-level, top-level authority for finding domains. Well, here's what I get back. I get back, look at the left column, it says net dot. These are all the servers that have authority for answering domain name questions that end in .net. And you can see that I get 13 more, A through L, gtld-servers.net. Again, randomly shuffled so that so that the load from the entire internet is distributed equally across here. These servers know how to answer .net questions. And so I ask them, hey, where should I go to find djp3.net? And you can see down below they answer, djp3.net? Oh, those questions can be answered by hover.com. 3 different name servers, name server 1, 2, and 3, shuffled randomly so that the load is distributed evenly across those 3 servers. Okay, so I go and I ask ns3.hover.com, where should I go to find www.djp3.net? And you can see almost at the bottom there that ns2.hover.com responded with 104.196.197.190, the authority that hosts the content for that domain name. The translation has been completed. You can see that that last step there alone took 87 milliseconds. If I go out then and ask for the content from that website, I get a snapshot of my website back. And you can see that the address that has been used, the IPv4 address, is hidden in the browser. The browser doesn't communicate that to the user, just keeps the domain name because that's what people are good with reasoning. That is a way that is a resource that people can reason with well. Now that last step took 80 some milliseconds, but overall the whole process took 2.4 seconds for just one translation. So what we build on top of this is the cache infrastructure. And a cache is going to remember a set of translations for fast lookup without asking that entire infrastructure. And it will keep those fresh for anywhere between 5 minutes and 2 weeks, depending on what sort of information it gets about that translation. Now in this diagram, you can see in the upper right is the fail-safe mechanism that we just described. But before we use that fail-safe mechanism, we're going to go through a series of checks to see if that translation is already known. So let's start down at the bottom. The user is asking for www.djp3.net, and let's say they're using the Firefox browser. That request is going to go to the browser, and Firefox maintains its own cache internally inside it, so that if recently that translation from djp3.net to IP address has happened, it will respond immediately and very quickly. Now, if Firefox has never seen that translation before, it's going to make that request to the operating system. And the operating system is going to do one of two things. The operating system is going to ask a host table, which is a file located on the computer that has a manual translation between domain names and IP addresses inside it. This is useful if you're doing development and you want your computer to think that there's a certain set of computers is answering a certain domain name query, but you really want to send it to a testing site, something like that. It's also useful if you want to play a practical joke on someone and have a request to a well-known website like CNN.com go to your personal website. If there's no translation that's permanently set up to bypass the DNS system in the host table, then the operating system maintains its own cache. It will look in that location for a translation. If the operating system has never seen this before, it will go out to the telecommunication provider that you're working with in order to see if that translation is present there. This would be a company like Cox or your university ISP or your work ISP, Verizon, O2, Orange. Companies like this provide a DNS cache to reduce the amount of bandwidth that's going out of their system to the rest of the internet, and also to make their clients have a fast experience with the internet. Now, if your ISP has not seen a domain name service translation before, it will then go and invoke the failsafe method that goes and asks the global internet. Now, when an answer is provided by the failsafe method, it comes back through all those different levels. It comes back through the telecommunication provider, through the operating system, and through Firefox. And each one of those levels is going to remember the translation so that the next time it happens very quickly. Now, if you've ever hired a company like I did with Hover.com to do this translation for you, you have to register with the global service provider what the official translation is. And sometimes you'll get the message that says, please be patient, allow 72 hours for this to take effect. And the reason why is because each one of these caches will continue to use the old address that it knew about for up to 3 days before it will go out and ask for a refreshed copy from the next level up. So, the key points here are that IP addresses, Internet Protocol addresses, are hard for people to remember, but they're easy for computers to use. Domain names are hard for computers to reason with, but they're easy for people to use. And what the domain name service does is it translates from domain names to IP addresses, using a global set of computers all coordinated together to give a uniform experience for how domains work on the internet. I hope that this helps give you some appreciation for the complexity behind the translation, and also helps you to understand if you're ever if you ever end up buying your own domain name or working with a domain name service, why they're asking you to do the different kinds of make the kinds of settings that they are asking you to set. Thank you for your attention.